We're going to move on now to our last part of the day, and this is our lightning talks, and I'm chairing this one. So we'll just get straight on into that. But the idea with this session, this part of the day, is really just to bring in some other thinking about data and the ways in which data is being thought about and used and explored in art practices and in design practices. So I'll start, bring my notes over. So obviously I'm here on the chair, but we're going to hear today from Carly Vickers, Sean Williams and Yulia. Now I just have to get my notes here. Yulia Brazauskayte. And they're all going to be online, and I'm just waiting for a cue from up there to see how we're going. Yes, we've got the thumbs up. And we'll start with Carly. So Carly Vickers is an interdisciplinary designer, researcher and lecturer within the UNSW Faculty of Arts, Design and Architecture. She holds a Bachelor of Music Studies in Performance from the Sydney Conservatorium of Music, a Bachelor of Design from UNSW, and is currently completing a PhD in interdisciplinary creative practice. Her research is practice-based and explores the visualisation of gesture in live music performance contexts. And in this presentation, that's what we'll be hearing about, that it will be describing the current practice-based research that explores the communicative potential of music gesture within music performance. So Carly, welcome. Okay, Carly, I think you're on mute.
Yes, sorry, how predictable of me.
Yes.
Hi, everyone.
Hello and welcome.
Thank you for having me today. Can you hear me okay?
We can hear you beautifully. And we can also see you beautifully. So thank you. Yes.
Thank you. Okay, so this presentation focuses on my recently completed PhD research titled Annotating the Performance Meshwork, Experimental Visual Listening Guides from Musical Gesture for Audiences who are new to classical music. As you've introduced, this research was practice-based and interdisciplinary, combining my work in design research and music research into performance contexts. So the research addressed Western classical music as a case study of live performance and examined the possibility of the musical gesture of the conductor to be used as real-time visual data for the benefit of the audience. And this benefit was intended as twofold. One, to increase the engagement of the audience by making the experience more visual, and secondly, to potentially increase the musical perception of the audience. Next slide, please. In this talk, I'll be looking at two of my research questions, which were the first, which was how can musical gesture be employed as a visual design material for the visual augmentation of live orchestral performance? And next slide, please. That's talking about this kind of image where you have a ticket at the back of the concert hall and you can't necessarily see what's going on or any of the detail of the performance. Next slide, please. And my second question, which was what insights into orchestral performance can the visual augmentation of conducting gesture offer new audiences to classical music? So I might just... So therefore, the research examined musical gesture as a form of live data that could annotate a musical performance. And the outcome of this first stage of the practice research looks like the following slide. So the following slide is a video, which we'll just play for a minute. I'm not sure if you have sound. So this is Symphony No. 9 by Brazauskayte. Thank you. You can stop it there. This visualization was generated in virtual reality using an Oculus system and the Unity software, capturing and translating the gestures of the conductor, as you can see in this image on screen. Next slide, please. My investigations built upon audience research studies that found more visual performances to be more engaging, especially for new audiences. Next slide. The visual nature of classical music performance has been addressed in a number of ways, such as this performance type. This is the Mozart effect, which puts programmatic images over the top of music. And also, next slide, there's a lot of work in projection mapping as interventions within concert hall architecture, such as this example with the LA Philharmonic and the work of Rafiq Anadol. Next slide, please. This research also built upon the notion of visual listening guides as printed or paper-based accompaniments to classical music, which often draw on data from the musical score. The work you can see on screen is a visual listening guide system by public musicologist Dr. Hannah Chan Hartley, which is used by the Toronto Symphony and demonstrates the symphonic score, which can often be hundreds of pages in length, down into a 2-page visual schema for viewing by the audience during the performance. Next slide, please. Another current approach to listening guides in the concert hall is the work you can see on screen by composer, pianist and software engineer Stephen Malinowski. So his work, The Music Animation Machine, creates a scrolling data visualization of the music that he also draws from the musical score and is often played on a screen above or beside the orchestra performing. Next slide, please. This assertion was based, building upon this notion of the listening guide, my research proposes that through the use of new technologies, musical information could be overlaid onto the live performance and generated as data in real time from the gestures of the performance itself, rather than constructed prior to the performance. So this assertion from my research was based in musical gesture studies, where a number of scholars have found musical gesture to be not only visually engaging, but to increase the enjoyment and musical perception of new audiences as well. Next. So this design research into music performance sits within the opportunity created by the overlapping potential of audience studies and musical gesture studies and existing research in those fields. Next, please. So musical gesture in orchestral performance serves a number of purposes: communication between musicians, communication between the conductor and the orchestra, communication of musical expression, also gesture for sound production on instruments, and the communication with the audience. So I've created an image here that shows the complicated communication that gesture plays when each player within the orchestra is coordinating with the others to produce the performance. Next. In addition to this is the work of, there's text up as well. This is the communication that happens between players and the conductor. So every single player is also gesturing in communication, not only with each other, but also with the conductor. Next, please. So conducting gesture is rich in information being communicated to an ensemble through a very particular means. That is tempo, which is the speed the music is playing at, rhythm and meter, which is some of the patterns you can see on screen, which I'm drawing onto a digital surface. Conductors also show dynamics, so how loud or soft something should be, timbre and instrumentation of the performance as well. So that's who is playing when and how they should be playing, and also stylistic approach. So musicians are trained in understanding and interpreting this gesture, but this research was interested in how much of this gestural information or gestural data could be understood by the audience. Next, please. So as I said earlier, to bring this into the concert hall, I looked to create images from this gesture in virtual reality, of which you can see some early stills on screen. Next. Through this gesture, I created both animations and what I called musical signatures that represented the gestural data of the performance. So this is a signature that came out of the full performance in its completion. Next, please. And then I spent a considerable amount of time working on and testing with audiences an aesthetic that would describe the full movement of the conductor's gesture and also be visually engaging. You can move through the next slides kind of one after the other. Here are some of the visual styles that the software can now generate in a performance, and the audience can see if they're wearing 3D glasses. In the next slide, one more over, you'll see a set of stills from the Dvorak performance that the opening video was showing as well. So And the next image will show an intention of how it looks in the concert hall. So if it were to be a musical signature, it can sit above the players, or if we look to the next image, it can also exist overlaid and coming directly from the body of the performers in close proximity so that it describes their movement very authentically. So what did I learn from testing these systems with audiences? Through focus groups, I found that the system holds potential for both increasing the visual engagement and musical perception of the performance for audiences. This was most successful when, in this scenario, the gestural data was perceived as having accurate proximity to the musician, who made it such the image then came directly from their body. And my participants understood the instrumentation of points throughout the composition. So that means they understood who was playing when previously they would have been too far back or not been able to understand that from the nuance of gesture without the visualization. And they were also more cognizant of changes and nuance in dynamic, tempo, and stylistic elements of the musical material. I'll leave it there. Thank you.
Thank you, Carly. Beautiful slides. I think we can really appreciate what the outcome of that research was, and I can imagine that being part of that performance would have been quite magical to have those visual cues in there as well. So we're going to move on to our next presenter, and which is also kind of got a focus on movement as well. So Yulia Brazauskayte is a design and academic at the University of New South Wales, Art and Design, and UTS College Sydney. With a background in product design, her practice-based PhD project explored movement-based interactions with technology. Through her experimental practice, Yulia reinforces characteristics of our embodied existence that allows people to communicate over distance in a dynamic, co-regulated and ambiguous way without the use of words or explicit written language. Thank you, Yulia. Just looking up.
Thank you.
Excellent.
Can you hear me well?
We can hear you, and now we can see you. Welcome.
Amazing, thank you. I'll try to use the clicker that I was provided to kind of navigate through of my slides.
Sure.
So I'm Yulia. I'm a product designer and interaction design researcher. I just recently completed my PhD, which was quite a long journey, and I wanted to focus on a small part of it. So on this slide, you see my interactive sound installation Undula, which some of you might have also seen last year at a Data Imaginary in Brisbane. But today I decided to focus on a slightly smaller part of my thesis, which kind of led my practice to explore Undula. So in today's talk, I want to question whether the efficiency of information transmission is all that matters in online communication. In the past few years, we've all experienced the social distancing restrictions caused by COVID-19 and have relied on communication technology for staying connected with our loved ones. Despite many benefits that these technologies provided, they're still incapable of adequately substituting for the feeling of connectedness that is experienced during the face-to-face interactions. It's possible that due to the predominant focus of the technological development on the efficiency of information transmission, the important factors such as implicit affective qualities of communication are becoming overlooked. To understand the prevalent focus of communication technology on the accuracy and efficiency of information sharing, it's important to understand how computer scientists and interaction designers define communication and human cognition in the first place. For some reason, perfect, it worked. So the early forms of computer-mediated communication were developed at the same time as the study of cognition entered mainstream debates. Researchers believe that the development of the first computer in the late 1950s created a metaphor that psychology could apply to human mental processing, which is referred to as computer metaphor to mind. Through an information processing approach to mind, cognitivists popularized the idea that cognition takes place solely inside the brain, with the body playing the role of an input-output device. Similarly, the development of binary computers inspired many researchers to compare human communication to information transmission between computational minds. In the late 1940s, one of the founders of cognitive psychology, George Miller, introduced information theory to the study of human communication. He described human communication as a mechanical system, and I quote him, "In most communication systems, the source of the information is a human being. This machinery operates upon the information and changes it into a pattern of sound waves that is carried through the air," end of quote. In his work, Miller claimed that the explicit transmission of information between a sender and receiver is a defining feature of human communication. The sender-receiver model of communication, also known as the information transmission metaphor, considers communication to be a linear, sequential process of sending and receiving of predetermined information through various channels from one agent to another. In other words, an individual is simply transmitting or decoding a signal like a machine. Arguably, Miller's model presents a narrow view that is significantly oversimplifying human communication. And recent studies in cognitive neuroscience propose that there is now enough empirical evidence to reject the disembodied theory of mind as biologically implausible. In recent years, scientists have argued for the broadening the scope of human cognitive systems beyond the brain, also to consider the embodied nature of communication. The embodiment theory critically challenges the information transmission metaphor. For example, biologists and philosophers Maturana and Varela discuss human social dynamics from a biological perspective. They explore the phenomena of coordinated behavior in living organisms, highlighting the variety of possible interactions from releasing chemicals to the temporal body matching or body movements. They disagree with the information transmission metaphor, or the tube metaphor, as they call it. They claim that from a biological perspective, communicative behavior is a coordination that occurs in social interactions. And I quote them, "Biologically, there is no transmitted information in communication," end of quote. The shift in communication studies was supported by a professor of philosophy and psychology, Stuart Shanker, and a professor of anthropology, Barbara King, who studied ape language. They proposed a conceptual shift from seeing communication as predefined information sharing to regarding communication as co-regulated interaction. Within this paradigm, defined as the dance metaphor, communication is seen as a dynamic, embodied, ambiguous, intrinsically creative and co-regulated interaction. Information is not pre-given. Instead, mutual understanding emerges in a continuous coordination between agents as they interact with and adapt to one another. Within this perspective, socially embodied interactions become a basis for social understanding expressed through shared rhythm and movement. The discovery of mirror neurons in the late 20th century provided a grounded justification for those theories. The mirror neuron mechanisms enable us to understand the enacted intentions of others as if the observed actions were our own. The development of the computers encouraged people to compare humans to machines, which affected how we understand human cognition and human communication. But we're not machines, and as the understanding of consciousness and human communication has taken new turns, it's important to translate these new improved paradigms to the design of communication systems. Embodiment theories are now widely accepted by human-computer interaction researchers and practitioners, as they recognize the role of the body and action situated in the world as inseparable aspects of cognitive processing. However, it appears that a low conceptual understanding of embodied approaches to communication remain prevailing. I proposed a shift from computer-mediated communication to a new paradigm, which I called technologically mediated embodied communication. The table on the screen compares discussed approaches. Within this paradigm, we shift the focus from the accuracy of information transmission to supporting actions situated in the world. We focus on the process and aesthetics of interaction rather than being goal-oriented and bound to the efficiency of information sharing. In the end, opening up space for designing technologies that facilitate connectedness. That's all. Thank you.
Thank you, Yulia. Very meaty. So really appreciate that. That's plenty to turn over in our minds. I'm going to bring now Sean Williams online. Sean is actually from Flinders University. He is an award-winning #1 New York Times best-selling author of 50 novels and over 120 short stories for adults, young adults and children. As well as his original fiction, he has contributed to shared universes such as Star Wars and Doctor Who, and collaborated with other authors such as Garth Nix. He's an affiliate of the J.M. Coetzee Centre for Creative Practice and is currently a senior lecturer in creative writing here at Flinders University. Sean, are you online?
I am here. Hello.
Hello, Sean. We're just going to bring up a visual. Yes, there you are. How are you?
I'm good. I'm sorry I'm not there in person. I'm self-isolating because my wife's a close contact and I didn't want to make anybody sicker than they had to be. So sorry I can't be in the same room with you. It would have been great. Now, am I using the clicker or not?
You can decide if you'd like to use the clicker. There is a slight delay, so don't be alarmed if you use it and there's a second or two.
No worries at all.
Thanks, over
Fiona.
to you.
Cheers. So I am a science fiction writer. I've always been interested in robots and AIs, etc. I grew up watching Doctor Who, hence my desire to write in that world. I'm also a keen collaborator. I've worked with other writers and in shared worlds. It's a natural progression for me, or it feels natural to me to find a way to interact with the kind of machines that I've been writing about and reading about since I was a kid. I'm less interested in the antagonistic kind of Kubrickian HAL from 2001 type robots with which we have an antagonistic relationship, or with the Star Wars droids kind of machines with which they are the slaves and we are the masters. I'm less interested in that kind of thing. I've been looking for an equal partner in a creative endeavour. I'm really pleased to be able to be joining with a bunch of wonderful people here at Flinders to pursue exactly this. So working with Tully, who's there in the room, Richard Librand, who I think is in the room there as well, from Science and Engineering, David Powers from Science and Engineering, and a couple of wonderful RAs. I think Bob is in the room as well. Again, sorry I can't be there with you. We are working to explore our overlapping interests in literature and the boundaries around literature to explore a project which puts the AI into creative practice in a collaborative way with humans. There are plenty of instances where AIs are producing creative work that are pitted against each other purely on their own after having been trained on various models. There's the Hoshi Shinichi Literary Award, for instance, which is pits applications from AI against those by human authors in blind trials. A really interesting award and a really interesting process. Not really what we're trying to do here. So we're responding to recent research in natural language programming to train AI interfaces in the act of writing, and specifically the act of writing like me, because I'm very lazy. And if a machine could do it for me, that would be great. So our research questions are, can AI be trained to formulate living writers' narrative outputs as opposed to recreating Shakespeare, which has been done over and over again? Can this AI-created draft be used as the basis of an AI-human author creative collaboration? How does AI-generated literary text complicate the future of reading and literary meaning making in a digital environment? Are these considered? We'll come back to this. It's a huge question. And what can we learn from this process to inform such future collaborations moving on throughout the industry and various other creative endeavours? So the original plan, was that we as a group, me and Tully and David and Richard, would select a number of texts for annotation, for analysis, which would incorporate all sorts of different elements of the text, including just the words. The AI would then produce a number of texts to which I would respond. We'd have a cycle building between me and the computer. We'd reach a creative output, and then we would produce an exegetical response to that and for the Academy to kind of experience. We decided that we would set the creative work in a world that was invented by me. This is a world that is freely available to students and staff in the university to operate in. We've got a bunch of other collaborative projects happening in there, including short stories and short films and so on and so forth. And now this work, the idea is that the AI will replicate that world and create stories in that world. And that all sounded great and fine until we started to do it. To quote the great German military strategist Helmut von Moltke, no plan survives contact with the enemy. Our enemy here was our ambitions and funding, of course. So everything has taken a little bit longer than we expected. We've had to rein in our ambitions a little bit. And of course, it's been a crazy year as well. So time has not been on our side as well. So our new plan is now we will do the same thing. We've selected the texts, both the texts that are set in this world, which is called the structure, and novels that I wrote around about that time, which capture the same style. Laura Savaglia, one of our RAs, is doing text analysis at the moment. Bob Wright in the room is working on the world creation to create a model of the structure in which these stories will take place. Ronan Idson-Wilkins will work on producing text in the end. Those stages are still underway at the moment. So what will happen in the collaboration phase is still to be determined, and the outputs are still to come as well. But they are underway. So you'll see on the screen a chicken. On the next screen, which hopefully should be coming up any second now. So now, if that's a video, I don't know how to play the video, but this is a video that Bob supplied of our virtual chickens operating in a virtual world. The idea is that, these are various agents, the red, green, and blue. They have particular desires and needs. They explore this world. In this case, the need is to eat. So they are running around eating those little objects there, the sort of virtual kind of food. They interact with each other. They get hungry. They go find more food. Once they've run out of food, they get really hungry and start eating each other. So it's quite a brutal dog-eat-dog kind of environment. Every time this program is run in Unity, we generate a text file is generated of what happens. It's a very, very basic text file, but a narrative of some kind is created from these basic interactions inside the program Unity. What happens next is that on the left there, you'll see the very basic text. It's fed into a GPT-3 Neuro-Linguistic NLP program. Apologies to any of my computer science people in the room if I'm getting any of the terminology right. That text is then adapted into something that actually reads like something a person would write. So instead of the chicken got hungry, the chick found some food, the chicken ate it, the chicken got hungry again, it becomes Debbie was looking for food when she arrived at the stables. She ate a burger and then chased, and so on and so forth. It becomes a very basic story. So the idea will be to build a really interesting, complicated world, set up people instead of chickens, and create stories from there. Now, this is a really interesting area that's changing constantly. This article came out just last week. A researcher, Thurstrom, asked their GPT program to write a paper about itself, and then they tried to get it published. And in the process of doing that, they had to answer various questions that suggested that the GPT-3 program had agency and identity, like it had to name itself as the first author. It had to give consent for its work to be published, which hasn't been published yet, but it's under review at the moment. So it'll be interesting to see if it does, because does that acknowledge that the GPT-3 program is an author, or does it not? What does it say about the origins of the text? So it's a fascinating area. We've got a long way to go. Our progress report, here's our progress report, illuminated by a picture from Night Cafe, which is a AI online program. This is a Night Cafe image based on the prompt, an exciting story set in the structure. Maybe the structure will look like that, I don't know. So we are anticipating that this semester will be the semester where we'll start generating some real result as we start building models and we start adapting the GPT-3 NLP program. We'll start bringing in some text that comes straight out of the machine and straight out of the simulated world. Then I will come in, we'll start collaborating with turning these raw events into narratives. considering handing some of these raw texts over to my editing and industry students as well, because editing is, of course, a very important part of the creative writing process as well. Be good to get them involved and see what comes out. So we'll have collaboration on two fronts. We might end up with short works, maybe micro or flash fiction under 250 words at first as a proof of concept. We might pit them against a human audience to see which is the best iteration, which isn't. We might have public readings. We might do all manner of things based on this text that comes out. And then I hope writing a novel will just be a matter of engineering, but I'm sure it'll be much more complicated than that. Now, this process is fun. It's very challenging, I think, on various fronts as well, in terms of legal ownership and so on and so forth. Who will own the text at the end of it? Trying to get the last screen up. It's not happening. But my hope is that we will develop a greater understanding of the creative and collaborative process through this exercise. Every craftsperson has tools that they use. I hope that we will generate a tool that I can use to write better work, not just new work. We will prompt difficult legal questions as to who owns this text and who doesn't. Does Flinders University own it? Does Laura, who did the programming with GPT-3, own it? Do we all own it? I love the idea that Tully, David, Richard, Bob, Ronan, Laura, and I all have a collaborative stake in this particular work, along with the machines and the AIs. These are all questions for the lawyers to discuss once we get the outcome to the next stage, which is saying, here, we've done it. Have we broken the law or not? So thank you all. That's where we are at the moment. Cheers. I hope I haven't gone long.
Thanks, Sean. Terrific. So 3 little research snapshots, if you like, to take away with us, all kind of thinking about how communication can be enhanced in and through our explorations and engagements with data. So interesting to draw those threads and think about those threads between those presentations. Interesting also thinking about that final presentation with Sean about AI and the writer. That actually takes us back to T's presentation yesterday. One of the questions from the audience was about AI and the production of art, which led to some some further questioning around the question, well, what is in fact art? Where do we, maybe that the question is not so much can AI do art, but do we need to rethink what art is? So maybe that's a question about the writers, and as Sean alluded to there's a lot of further questions that will go back to the legal teams who are sort of managing and overseeing this next part of the digital journey that we're all on.